Good morning, second grade. Ms. Fogelman here today for your math lesson. Okay, so today our learning target is the student will answer problems using the data from a bar graph. Before we begin, I did want to do a review of bar graphs and pictographs. It's been a little bit since we've done them. So I want to show you this video.
Twelve cat owners were asked, what color is your cat? Is it gray, brown, white, or black? They made a first draft of a bar graph, and that's what we're looking at. One axis on the graph shows the number of cats. The other axis tells us if they're gray, brown, white, or black. And now we can compare each group of cats there, like the fact that there are 2 more gray cats than black. On a bar graph, the data there can be put together, taken apart, or compared. Picture graphs can show the same data you see, except with pictures and a key. The safari guide was asked, where are the most giraffes? In the water, by the trees, or on the grass? He drew them up a draft of a picture graph, and that's what we're looking at. One axis on the graph shows the number of giraffes. The other tells us if they're in the water, by the trees, or on the grass. And now we can compare all the tall giraffes there and see there's 1 giraffe more by the trees than on the grass. On a bar graph, the data there can be put together, taken apart, or compared. Picture graphs can show the same data you see, except with pictures and a key.
Let's look at a bar graph showing all of the giraffes in the water, by the trees, or on the grass. And see that every time we craft any type of bar graph, we label the axes and write a title on each draft. And it shows us that in all, 10 giraffes are standing tall on a warm summer day in Senegal, roaming the plains by calm seas, eating fruits, flowers, and leaves from different species of acacia trees.
On a bar graph, the data there can be put together, taken apart, or compared. Picture graphs can show the same data you see, except with pictures and a key.
Okay, that video gives us a good review of both bar graphs and pictographs. Today, we're going to specifically talk about bar graphs. Okay, so our data here shows us the average lifespan of 3 animals: the queen bee, the kangaroo, and the koala. The queen bee's lifespan is 5 years, kangaroo is 9, and a koala is 8. So if we look at our bar graph at the bottom, we have the queen bee in our bar graph. As you can see, this axis on our graph shows the animal's name. And then this one shows us the lifespan in years. So the queen bee, as we said, was 5 years. The koala is 8. So now we have to figure out how high up to take our bar for kangaroos. The kangaroo's average lifespan, according to our data, is 9 years. So we need to take our bar graph up to the 9, because that shows that the kangaroo lives for about 9 years. Now that we have all our information in the bar graph, we can then compare the different animals. So for example, if I said, how much longer does a kangaroo live than a queen bee? You could say 9, which is the number of years a kangaroo lives, minus 5, because that's the number of years a queen bee lives, equals 4. Okay, so another question that we could have is how many years less does a koala live than a kangaroo? So again, we would have 9, which is the average lifespan of a kangaroo, minus 8, and that equals 1. So both of these questions could be answered by looking at our bar graph data. Today, I want you to go into Shobi to our math slide. And right here, there is a Google form I want you to take. This graph has to do with these 2 questions. And then this graph has to do with these 2 questions. And then again, make sure you hit submit so that your score comes to me. All right. I think that's all I have for you in my lesson today, but make sure to get that work done and have a good day.